Good morning to everyone. Today I discuss the current source inverter. Previous chapter I discussed the half bridge and full bridge inverter, series inverter, parallel inverter. Okay, so today I discuss the topic on current source inverter. Before going to current source inverter, there are two types of inverter according to the source. Okay, first is voltage source inverter, voltage source inverter, and second is current source inverter. There are two types of inverter. I already discussed the classification of inverter, okay, or types of inverter. So there are two types of inverter according to the source. So first is voltage source inverter and current source inverter. Okay, so I differentiate voltage source inverter and current source inverter. Voltage source and current source. Okay, what is voltage source inverter and what is current source inverter? A voltage source inverter is a constant voltage source, constant voltage source which supplies AC to the output. AC to the output means which is a constant voltage source which supplies AC to the output. So output is a constant voltage. Output provides the constant voltage, and constant current source is a constant current source which supplies AC to the output. Okay, so secondly, load voltage. So load voltage is constant. Okay, and here the load current is constant. Okay, load voltage is constant, here the load current is constant. Thirdly, it is also called voltage control inverter. Okay, it is also called voltage control inverter. And for current source inverter, it is also called DC link inverter. Okay, it is called voltage control inverter, and current source inverter is also called DC link inverter. Fourth is use of feedback diode. Okay, so here in voltage source inverter the feedback diode is used, or diodes are used, okay, for voltage source inverter. But in current source inverter no diode is used, no feedback diode. Okay, fifth is in voltage source inverter the source current may be reverse. Okay, reverse means the feedback feedback path is available, so the feedback is goes to the input, so input may be a reverse. Okay, and in the current source inverter, source current no reverse, no reverse. This is the fundamental differences between voltage source inverter and current source inverter. I already told you or read you the voltage source inverter. The example of voltage source inverter is series inverter, series oblique or parallel inverter. Okay, series inverter or parallel inverter is the example of voltage source inverter. So I already discussed the voltage source inverter, which is series inverter and parallel inverter. Okay, so today I discuss the current source inverter. Okay, what is the current source inverter? Okay, and why it is called the current source? So in the current source inverter, a voltage source converted into a current source. Okay, here the voltage source converted into a current source. So the diagram, the voltage source, the current source inverter diagram shown in a voltage source. This is a voltage source, okay, which is denoted by V in, and it's connected in series with inductor. This is called the current source, and total V in means voltage source in series with a inductance is called a current source, okay. A voltage source in series with inductance is called a current source. So this is the current, this current is source current. Okay, here 4 thyristor is used. Okay, 4 thyristors are used. Okay, fourth thyristor is used, and load is connected between these two terminal. This is the load. Okay, this the A point is denoted, and here the B point is denoted. Okay, the thyristor is T1, and thyristor is T4, and thyristor is T3, and thyristor is T2 or SCR, thyristor or SCR. Okay, so here few point. First point is that voltage source with a inductor in series is called current source. Okay, a voltage source in series with the inductor is called, this is called a current source. They act as a current source. Okay, second point is 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 the source current. Okay, this is the IS is called the source current, which is constant. The source current is constant. Let the load, here I discuss when the load is resistive, means the load is purely resistive, means a R is connected, R is connected across the load, means load resistance is connected across the A and B terminal. Okay, so operating principle. Okay, here the waveform is, so this is the waveform. This is the I0 means output current, this is the V0 means output voltage, and this is the V in. V in is a DC signal, so this is the V in. Okay, this is the V in, it is also a DC signal, so you obtain the output current and output voltage. Okay, so when output current and output voltage is obtained, so at first for 0 to T by 2, for the time period 0 to t by 2. Okay, for the time period 0 to t by 2. Okay, t1 and t2 are triggered. Okay, t1 and t2 are triggered means a pulse is applied to the gate to switch on the t1 and t2. So it is called the triggered. When we triggered t1 and t2, so t1 and t2 is on, so a current flow from t1 to load, okay, this direction, t1 to load, this direction, a current flow. Okay, t1 to load to t2, this direction, a current flow. Okay, so if this current flow, so a terminal is positive and b terminal is negative. So a terminal is positive and b terminal is negative. And here also I0, this is the load current I0, this is the load current I0 is equal to the IS, is equal to the IS. Okay, I0 is equal to the IS. So this is the IS which is positive, so positive IS, and this is the positive, so this is the positive IS, this is the positive. Okay, next here, when the time period, okay, when the time period t by 2 to t, means this time period t by 2 to t, this time period, okay, triggered T3 and T4 by external pulse is applied to the gate, so T1 and T4 is on. And here also a current flow from T3 to load to T4. Okay, T3 to load and T4. Okay, so A terminals becomes negative and B terminal becomes positive. Okay, and I0 output current equal to the minus of IS. So this is the minus of IS. So when the T1, so A becomes negative because it is the negative and it is the positive, the current flow T1 positive to negative terminal, so this direction is current flow, so A becomes negative and B becomes positive. So I0 output current is equal to minus of IS, because minus of IS means we consider the IS this direction. Okay, this direction for first direction, plus IS means when the A is positive and B is negative, but when A is negative, B is positive, the direction of current is opposite, so opposite direction current is called the minus of IS. We consider the IS A, this is the A terminal, A and B, this is the IS, so A positive and B is negative. When A is negative, B is positive, the direction of current is this direction, so IS becomes minus of IS. So I0 equal to the, so I0 equal to the minus of IS. Okay, so at this t by 2 to t by 2, the IS is negative, so this point IS is negative. So the output voltage V0, V0 is equal to positive when we know V0 is equal to I0 into R, means this is the load is resistive, we consider the load is resistive, so voltage equal to V is equal to IR, so output voltage is equal to output current into output resistance. So here output voltage V0 is equal to I0 at the first case, as the first case when 0 to t by 2, when the time period 0 to t by 2, I0 is equal to plus, I0 is equal to IS, this the I0 is equal to IS which is positive, so V0 is equal to plus IS into R which is positive, positive. So output voltage is positive at the 0 to T by 2. Okay, next T by 2 to T. This is the output voltage. Before we consider output current, then output voltage T by 2. So V0 is equal to I0 into R, because output current into resistance. Here the output current is minus of Is. We considered this is the I0 is equal to minus of Is. So minus of Is into R, V0 equal to, okay. So output voltage is negative at the time for T by 2 to T. So at the time of T by 2 to T, the output voltage is negative. So here DC voltage is applied and AC output current and AC output voltage is obtained, and this is the constant. So it is called a constant current source inverter. So we also consider, we explain the principal operation when the load is resistive. Now I discuss when the load is capacitive, means a capacitor is connected across between the A and B. Here a capacitor is connected between A and B as a load. Capacitor C. Here the capacitor C is connected. Before I discuss, here a resistive load means R is connected across A and B. Now we discuss when a capacitor is connected as a load. So what happened? So we know that the output current is same as resistive load, because when 0 to T by 2, T1 and T2 are triggered, so I0 is equal to plus Is, and when T by 2 to T, T3 and T4 are triggered, and I0 is equal to minus of Is. So output voltage, we know that for capacitor, V lag by V lag I by 90 degree. ঠিক আছে, voltage V lag I by 90 degree. ओके, तो क्या होगा ना, ये lag, this is the 90 degree, this is the voltage lag, this is the current lag means before. Okay, lag means before, means output current is going, then output voltage is going. First output current is going, then output voltage is going. So here output current is going, then output voltage is going. And we know I0 means output current is equal to, I0 is equal to the capacitor current, which is denoted by IC, is equal to C dV0 by dt. This is the voltage current equation. This is the current equation of a capacitor. Okay, so if we at this equation, from this equation we determine the value of V0t. So 1 by C integral of I0 into dt. From this equation we determine the value of V0t. So 1 by C integration of I0 into dt. We know if integration of rectangular wave, if integration of rectangular wave, we get the triangular wave. Okay, so integration of rectangular wave is the output is triangular wave. So the triangular waveform is obtained. Okay, so triangular waveform is obtained when load is connected as a capacitor. So it is the mainly discuss the current source inverter when load is resistive and when the load is inductive. Load is resistive and when the load is capacitive. Okay.